Ohio State University, together with my colleague, Dr. Jiawi Lu. We have an exciting tutorial for you at the supercomputing. It is titled Accelerating Big Data Processing with Apache Hadoop, Spark, and Memcached on Modern Clusters. As many of you know, we are in an exciting phase in the field of high-end computing, trying to aim for efficient processing or accelerating a lot of big data related processing. So big data is coming in a big manner with a lot of data being available to us, and the challenge is how do we process this in an efficient manner to make sense out of this data. So if you take a look at how much data is being generated, here we get a very nice representation of the amount of data being generated. For example, if you take like a Facebook, almost 4 million posts are being made per minute. Similarly, YouTube, if you see, almost 300 hours of new videos are being uploaded, and the list keeps on going. So with this kind of big data which is being generated, the question is how we can process them efficiently to make sense out of it. So in this case, if you take a look at currently the representative data center, you will see in the front end here, typically we have components like Memcached together with a database, might be running with MySQL. There are also NoSQL database where HPC is being used. And in the backend tier, we have the standard Hadoop, Spark with MapReduce and with HDFS, those kind of components. So this kind of architecture is scalable, but at the same time, it is very communication intensive. So traditionally, these software stacks and the middleware have been designed with the standard sockets interface. And the standard sockets, as you can see, can either run over the traditional Ethernet environment from 1 gig to 10 gig to 100 gig, or it can also run on the modern networking technologies like InfiniBand, but with a mode which is called IP over IP. But then, if you take a look at some of this performance, you will see that neither of these are very efficient, and the sockets are not designed for environments like, especially if you take a look at the top 500 systems, you will see the technology which is more like the InfiniBand with the RDMA. Protocols are gaining a lot of prominence. This is like in the slide which is showing in the lower bottom, which is the increasing the share in the market of the top 500. So in this context, we have a lot of different kinds of protocols which are being proposed, especially in the Open Fabrics environment. So here we can see that on the left hand side we have these are the standard Ethernet environment, those which are trying to use the sockets interface, but the main performance benefit we see on the right hand side, which is like the IB natives, but here one has to use the verbs interface to exploit the performance. So that leads to the challenge that can big data processing systems be designed with high performance networks and protocols? For example, if the current Hadoop or Spark stacks are written with the sockets and are not able to scale, can we try to rewrite or redesign for them to run over verbs interface so that they can actually help to accelerate the performance? So in this context, the broad question is that how can HPC clusters with high performance networks benefit big data applications? Different people have different questions saying what kind of popular programming models and architectures are there for big data processing? What are the major bottlenecks in current big data processing middleware? Can the high performance interconnects benefit big data processing? Can these bottlenecks be alleviated with new designs similar to, let's say, how the MPI, which is the message passing interface stack, which has been redesigned over the last 15 years to run very efficiently with RDMA enabled networks like InfiniBand. And at the same time also, can HPC clusters with parallel file systems like Lustre benefit big data applications. And if we try to redesign these stacks, how much performance benefits we are expected to achieve. And in these kind of environments with the enhanced designs, how do we design benchmarks to really evaluate the performance of the big data middleware? So broadly, this leads to the questions again, like can the HPC and big data processing be put together into a convergent trajectory, because they have been like trying to go into questions. We have put together a very interesting tutorial here. This will be the outline of the tutorial. We'll try to provide first an overview of the MapReduce and the Spark RDD programming models. We'll go into the architectures of Apache Hadoop, Spark, Memcached. We'll take a look at the modern interconnects and protocols. Then we'll try to take a look at the challenges in accelerating all these stacks. We'll try to provide you an overview of benchmarks and applications. And then we'll also try to go into a lot of detailed case studies and in-depth performance evaluations of accelerating the different components of the middleware and what kind of performance benefits you can expect to gain from there. And then we'll try to introduce this high performance big data project or high BD project, where we have been carrying out a lot of these accelerations, and over the years we are trying to make these stacks available publicly for people to use this. And then we'll conclude this tutorial with an overview of ongoing and future activities for accelerating the big data applications. So broadly, we have an exciting tutorial here to answer all questions related to acceleration of the big data. So this will be held on Sunday, the November 13th in the afternoon, room 255F. And I hope many of you will be able to join us. If you have any questions, please feel free to contact me or my colleague as indicated here. So we look forward to seeing you at the supercomputing and this tutorial on Sunday. Thanks.